Well friends, welcome to chemistry online classes. Today I am going to discussing about the packing efficiency. During the close packing of particles in a crystal lattice, there is a vacant space is present between the particles. That is in the form of void. Void is nothing but water. There is a vacant space present between the particles is called a void. There are two types of voids, you know. One is a tetrahedral void and the other one is a octahedral void. Okay. In last class, you know what is the relationship between the number of voids and the number of particles present in a unit cell. If n number of particles are present in a crystal lattice or a unit cell, now if the 2n number of tetrahedral voids and n number of the same number of what there is a octahedral voids are present. Octahedral voids. These are tetrahedral voids. Present in a crystal lattice. Now, I am going to discussing about what's the meaning of a packing efficiency. Packing efficiency ಅಂದ್ರೆ ಏನು? ನಿಮಗೆ ಗೊತ್ತಿದೆ ಆಲ್ರೆಡಿ. ಒಂದು ಯೂನಿಟ್ ಸೆಲ್ ಒಳಗ ಪಾರ್ಟಿಕಲ್ ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇಕ ಮತ್ತು ವಾಯ್ಸ್ ಇಕ ಏನು ರಿಲೇಷನ್ ಇದೆ ಅಂತ. ಒಂದು ಕ್ರಿಸ್ಟಲ್ ಲ್ಯಾಟಿಸ್ ಒಳಗ n ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇದ್ದು ಅಂತಂದ್ರೆ ಅದರ ಡಬಲ್ ಟೆಟ್ರಾಹೆಡ್ರಲ್ ವಾಯ್ಡ್ಸ್ ಇರ್ತಾವ, ಅಷ್ಟ ನಂಬರ್ ಆಕ್ಟಾಹೆಡ್ರಲ್ ವಾಯ್ಡ್ಸ್ ಇರ್ತಾವ ಅಂತ ಗೊತ್ತು. Now packing efficiency means the percentage of space occupied by the particles in a crystal lattice. What? In a crystal lattice, how much percentage of the space is occupied by the particles? That's nothing but what we are going to call as a packing efficiency. See here, this is nothing but the shape of the particle present in a crystal lattice or in an unit cell. See here, packing efficiency is equal to, that is, a volume occupied by the particles dividing by volume of unit cell into 100. This is nothing but what packing efficiency. See here, just you consider it is a unit cell of FCC. If the particle is present like this, here in certain space that should be occupied by this particle. If we are going to arrange in a different corner or at the center of the body or the center of the basis, that space is occupied by these particles. Nothing but the volume occupied by the particle dividing by volume of the unit cell into 100. Now, volume occupied by the particle is equal to occupied by the particles is equal to Z, it means the number of particles into volume occupied by the one particle. If a unit cell has one number of particle, that is nothing but the volume of this particle. The volume of the space occupied by the particles in unit cell is nothing but the volume of one particle. If a unit cell has two particles, 2 into, that is the volume occupied by this one particle. If a particle has if a unit cell has a 4 number of particles, in case of the FCC, you know, FCC unit cell has the 4 particles. There is a 4 into volume occupied by this particle. Therefore, the total volume occupied by the particle is equal to number of particles into volume occupied by one particle. This is equal to Z into the volume of this is nothing but the shape of this one is nothing but the sphere. Therefore, 4 by 3 what by R2. This is the volume of the sphere. ನೋಡಿ ಒಂದು ಯೂನಿಟ್ ಸೆಲ್ ಒಳಗ ಒಂದು ಪಾರ್ಟಿಕಲ್ ಇತ್ತು ಅಂತಂದ್ರೆ ಅದು ವಾಲ್ಯೂಮ್ ಆಫ್ ಸ್ಪಿಯರ್ ಆಗಿರ್ತದ. ಒಂದು ಯೂನಿಟ್ ಸೆಲ್ ಒಳಗ ಎರಡು ಪಾರ್ಟಿಕಲ್ ಇದ್ದು ಅಂತಂದ್ರೆ 2 into ಹೌದಾ ವಾಲ್ಯೂಮ್ ಆಫ್ ದಿಸ್ ಸ್ಪಿಯರ್ ಆಗುತ್ತೆ. If the particle unit cell has a Z number of particles, then the Z into volume of the sphere ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ನಾವು ಇಲ್ಲಿಂದ ಬರೀಬಹುದು ಅಂತಂದ್ರೆ ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿ ಅಂದ್ರೆ there is a Z into 4 by 3 pi r cube dividing by this is a E cube. E cube means it is the size of the edge length of the unit cell into 100. This is nothing but what we are going to call as a packing efficiency. Now I am going to discussing about packing efficiency in simple cube. See here please. Draw a unit cell of the simple cube. Just this is a shape of the unit cell. Simple cube cubic unit cell. Now, in case of this simple cube, particles are present on the edges like this. Okay. Then, including this corner, what happens actually? See here. This is the unit cell of the simple cube. The particles are present on the edges of the simple cube. See here, ABD edge length and RBD radius. Okay. Now, in case of the packing efficiency, in a simple cube. See here. Let us consider a unit cell of the simple cube. Small ABD edge length of the simple cube and RBD radius of the simple cube. A is equal to just that is A is equal to 2R because the AB is equal to edge length is equal to just that is a R plus R, that is a 2R, that is a A is equal to 2R. In every case, to determine the packing efficiency, first of all you have to determine the relationship between the edge length and the radius of the particle. That is the A is equal to 2R. ಪ್ರತಿಯೊಂದು ನಾವು ಯೂನಿಟ್ ಸೆಲ್ ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿಯನ್ನು ತೆಗಿಬೇಕಾದ್ರೆ ನಾವು ಫಸ್ಟ್ ಕಂಡುಹಿಡಿಯಬೇಕಾದಂತದ್ದು ಅಂಶ ಅಂತಂದ್ರೆ ಎಡ್ಜ್ ಲೆಂತ್ ಮತ್ತು ರೇಡಿಯಸ್ ಆಫ್ ದಿ ಪಾರ್ಟಿಕಲ್ ಏನು ರಿಲೇಷನ್ ಇದೆ ಅನ್ನೋದನ್ನ ತೆಗಿಬೇಕಾಗುತ್ತೆ. ಈಗ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ಇದು ಏನಿರುತ್ತೆ ಆಟೋಮೆಟಿಕ್ ಆಗಿ ಇದು ಏನಿರುತ್ತೆ ಅಂದ್ರೆ ಇದು ಆರ್ ಆರ್ ಇತ್ತು ಅಂತಂದ್ರೆ ಎ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಾಗಿರ್ತದೆ ಅಂತಂದ್ರೆ 2R ಆಗುತ್ತೆ. Now therefore you should write 4 points. Edge length is equal to that's A that's equal to 2R. Number of particles in an unit cell. In a unit cell, that's nothing but the z. This is equal to 1. In case of the simple cube, the particles that are present in the corner, that is the number of particles is equal to 1 by 8, because of 1/8 part of this particle is saved by this unit cell if it is present in the corner. Therefore 1/8 into 8, this cancel, this is equal to what? 1. Now volume of a particle or sphere, one particle is equal to what? 4 by 3 pi r cube, you know. Then volume of tube is equal to, what is the volume of this tube? Length, breadth, height. A, that is the volume of tube is equal to what? A cube. Now put these values in case of the packing efficiency formula. That the packing efficiency is equal to Z into 4 by 3 pi r cube divided by a cube. Now packing efficiency is equal to, what is the value of the Z? 1 into 4 by 3 into pi r cube divided by, what is the value of A? That is, A is equal to 2r whole cube into 100. See here, that is a 4 by 3 into 8, that's a r cube is a cancel, into 22 upon 7 into 100. This is equal to, that is a 52.33. This is the percentage of the space occupied by the particle in case of this simple cube. This is the packing efficiency in a simple cube. Now the percentage of empty space in a simple cube is equal to 100 minus 52.3, that's nothing but the 47.7. 47.7 is a percentage of empty space in the simple cube arrangement. Okay, now this is nothing but the what a packing efficiency in case of the simple cube. Now I am going to discussing about what is the packing efficiency in case of the FCC unit cell. See here friends, there is what is the packing efficiency? Packing efficiency means the percentage of the space occupied by the particle. You know, 100 value ಮತ್ತು ಎಷ್ಟು value ಆ particle ದಿಂದ space occupy ಆಗಿರುತ್ತೆ ಒಂದು ಕ್ರಿಸ್ಟಲ್ ಟೈಪ್ ಒಳಗ, ಅದಕ್ಕೆ ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿ ಅಂತ ಹೇಳ್ತಾ ಇರ್ತೀವಿ. Packing efficiency ಅಂತಂದ್ರೆ volume occupied by the particle to the volume of the unit cell into 100. Volume of the unit cell into 100. ಆ unit cell ಒಳಗ unit cell ವ್ಯಾಲ್ಯೂಮ್ ಎಷ್ಟಿದೆ, ಮುಂದೆ ಆ ಪಾರ್ಟಿಕಲ್ ದಿಂದ ಎಷ್ಟು ವ್ಯಾಲ್ಯೂಮ್ ಆಕ್ಯುಪೈ ಆಗಿದೆ ಇಂಟು 100 ರಿಂದ ನಾವು ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ ನಮಗೆ ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿ ಬರುತ್ತೆ. ಇಲ್ಲಿ ಸಿಂಪಲ್ ಕ್ಯೂಬ್ ಒಳಗ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಅ ಸಿಂಪಲ್ ಕ್ಯೂಬ್. ಈ ಒಂದು ಸಿಂಪಲ್ ಕ್ಯೂಬ್ ಅನ್ನು ತಗೊಳ್ಳಿ. ಲೆಟ್ ಎ ಬಿ ದಿ ಎಡ್ಜ್ ಲೆಂತ್ ಆಗುತ್ತೆ ಅಂಡ್ ಆರ್ ಬಿ ದಿ ರೇಡಿಯಸ್ ಆಫ್ ದಿ ಪಾರ್ಟಿಕಲ್ ಆಗುತ್ತೆ. In a simple cube, the particles are present on the edges. Just to know, this is the shape of the simple cube, unit cell of the simple cube. Now, first of all, now what is the relationship between the edge length and radius of the particle? Now, in case of the simple cube, there is a edge length EB is equal to, there is a R plus R. That is the A is equal to 2R. Now we have to write these 3-4 points. The first one is the edge length A is equal to 2R. Number of particles in the unit cell Z is equal to 1. Because the particles in simple cube ಏನಾಗಿರುತ್ತೆ ಅಂದ್ರೆ ಪಾರ್ಟಿಕಲ್ ನ ಕಾರಣಗಳು ಮಾತ್ರ ಇರುತ್ತೆ. ಅದಕ್ಕೆ ಕಾರ್ನರ್ದೊಳಗಿದ್ದಾಗ ಅದರ 1/8 ಪಾರ್ಟ್ 1/8 ಭಾಗ ಮಾತ್ರ ಏನಾಗಿರ್ತದೆ ಅಂದ್ರೆ ಈ ಯೂನಿಟ್ ಸೆಲ್ಗೆ ಶೇರ್ ಆಗಿರುತ್ತೆ. ಈ ಕಾರ್ನರ್ ಹೋಗಿದ್ದು 1/8, ಈ ಕಾರ್ನರ್ ಹೋಗಿದ್ದು 1/8, ಈ ಕಾರ್ನರ್ ಹೋಗಿದ್ದು 1/8 ತಗೊಂಡಾಗ ನಮಗೆ z ಎಷ್ಟು ಬರುತ್ತೆ ಅಂದ್ರೆ ಆಲ್ರೆಡಿ ಯು ನೋ z 1. Then the volume of the particle is 4/3 pi r2 and the volume of cube is equal to ಏನಾಗುತ್ತೆ a cube ಆಗುತ್ತೆ. You know the formula packing efficiency, that the z is equal to 4/3 pi r2 into divided by a cube into 100. Put the value of a as of 1 into 4/3 into pi r2 divided by 2 r whole cube. Then by simplifying we get a 52.33%. This much space is occupied by the particle in case of a simple cube. ಹೌದಾ? ಇನ್ನ percentage of empty space in a simple cube ಎಷ್ಟಾಗುತ್ತೆ ಅಂದ್ರೆ 47.7% ಆಗುತ್ತೆ. This is a packing efficiency in case of the simple cube. ಒಂದು ನಿಮಗೆ annual exam ನಲ್ಲಿ ಇರ್ತದೆ ಅಂದ್ರೆ ರೇಡಿಯಸ್ ಕೊಡ್ತಾರೆ, metal atom forms a simple cube crystal lattice. There is a length of the unit cell is this much. Calculate the radius of the particle ಅಂತ ಕೊಡಬಹುದು. Then radius ಕೊಡ್ತಾರೆ, edge length ಕೇಳ್ತಾರೆ. ಅದಕ್ಕೆ ನಿಮಗೆ the relationship between the edge length and the radius should be, you should know in case of the simple cube. This A is equal to 2r. Okay, today I am going to stop here.